Hey guys, did you know that you can create some powerful 3D interactive maps using R? That's right. In today's tutorial, I'm going to show you how you can leverage the power of DeckGL to create a 3D population map of Switzerland using Kontur data. We'll be taking two steps in this tutorial. The first step will be to load the Kontur population data for Switzerland into R, and the second step to use DeckGL to create a 3D interactive population map of Switzerland. All right, guys, let's get started by first of all installing and then loading the packages we need. I'm here going to define a list of libraries, which is going to be called libs, and then the first package we'll need is the SF package because the population data from Kontur comes in the shapefile format. So the best way to deal with shapefiles in R is to use the SF package. The second one, once we download this file, it's going to be in a gunzip format, and for that we need a specific library which is called r.utils for extracting these files. The fourth or the third one is the scales, a package which we'll be using for assigning, well, first of all defining quantiles for our population data and then assigning certain colors to each of the quantile values. And the final one is the DeckGL package we'll be using for creating this beautiful 3D population interactive maps. And this one is based on an open source JavaScript library called deck.gl. And here it's translated to R, which really gives a lot of opportunity for creating some beautiful 3D interactive maps, as you will see in this tutorial. Okay, now that we define this, we first of all need to see if we have these libraries, if they're already installed. That's why I'm creating here an object called installed libraries. And then I'm using this list called libs and going into the row names of already installed packages. So this is going to make sure that we actually see what are the packages that are not installed, and they're going to be stored here in this install libraries object. So then if any of these install libs or install libraries equals false, in other words, if they're not installed, then I write here that we should install them. So please install .packages, but we don't need all the packages. We need those from the libs that are not among the installed libraries. Okay, and then the final thing, once we install these packages that we lacked, is to actually load them, which in R is pretty easy. So here, because we are dealing with a list of libraries, we need to use lapply. So basically we are applying to this list of libs a function which is called library in R, and this function is used for loading packages into R. So in today's tutorial, we'll be mapping population using the Kontur global population dataset organized by hexagons. And this dataset was actually created by pulling together different sources, from global human settlement layer to Facebook high resolution settlement layer, then to Microsoft building footprint, and finally OpenStreetMap. I used it in one of the previous tutorials to create some pretty 3D population maps using Array Shader. And this time we'll be using the freshest data from 2023, end of October, and I'm really excited to try it out again. So what you can see here is a link that I fetched from the website, and let's show you quickly how you can do that. We start off by first of all looking for Kontur population. You can do that in Google, and then you should go to this humanitarian data exchange, which says global population density for 400 meters H3 hexagons. You click on this one, and this one will take you to this web page where you can actually get per country subsets of Kontur population. So you can click here on this one, and then over here you can search for the data set. So in this tutorial, we're going to be creating a 3D map of Switzerland. So I'm here looking for Switzerland. And once I found that, I should take this population density for 400 meters H3 hexagons. So the data of Kontur is organized in hexagons. We click here, and here it can actually show us how this looks like. You can zoom in or zoom out. And finally, what we need is the data for 2023. So this is the second row, which was added on 31st of October 2023. So you can either directly download this to working directory, or what we're going to do is simply copy the link address, and then within R, we're gonna start to downloading this to our local drive. Okay, now you know where I got the data and how you can get the data for other countries. Truth be told, actually, you don't even need to go to the website. What you should do is simply change this CH, which is the ISO2 code for Switzerland, with the ISO2 code for your country of interest. That's about it. All right, the first thing we're gonna do is we're gonna convert this into a string and define it as URL. Also, in case you have a slow internet connection in your place, you can here, first of all, set in options a timeout and increase it, let's say to 300 seconds. You can even take more. So this is a trick I wanted to show you. Then once we do that, we're going to define our file name, and the file name is going to be based on the base name of this URL. And in our case, that's going to be this part. So the name of the file, which is also zipped. All right. Then we need to download the file, of course. So for that, we use download file. URL is defined as URL. Destination file, we can use this newly created file name. And then finally, the mode of the download is going to be binary. All right. Once you download this file to your local drive, we need to unzip it. And as I said before, for that, we need to use our utils package. And this one has a function called gunzip, which is used for extracting exactly GZ or GZ files that we have currently. So basically, we're going to pass here the file name. So this is what needs to be extracted. And finally, we're not going to remove the original file once we extract. The next step is to, of course, load the data using the sf function stread. I'm going to call this pop_df, and then I'm going to use from sf package stread. And then here I'm actually gonna pass to this DSN variable, which is basically the name of your shapefile. I'm gonna use that file name that we have, but I'm actually gonna strip that GZ extension from it so that it only has SHP, so that we can actually load with this one. So for that, I'm gonna just use gsub from base R. So the pattern that we wanna discard is gz. And then replacement is going to be basically an empty string, which means we just want to get rid of it. And finally, this should be applied to the file name. Okay, so this is actually going to load that file that we have. And then the final step is to transform this. So this comes in a pseudo Mercator coordinate reference system, and I want it to be in the standard WGS84. So for that reason, I'm going to transform it using st_transform from the SF package. And then here for CRS, I'm basically going to say EPSG4326, which is code for WGS84 coordinates reference system. And then the penultimate step before we start creating a map is to define the palettes here. The easiest way is to use the scales package and then map certain palette to certain values. So for that purpose, I'll be creating here an object called pal, and then from scales, I'll be using one of the options. So I'm going to be using quantile. So I'm going to be creating here based on quantile probabilities and assign a certain palette then to quantile probabilities of our population count. Okay, so first of all, for the palette, I'm going to be using viridis, which I often use when I want to deal with, let's say, when I want to present population count. The second one is the name of the column that's for which we want to create these. So that column is called population, and it resides in this pop_df. And finally is the number of these breaks that we want to create, and I'm just going to put here, for example, 6. All right, so this is actually going to create the function that is going to help us now in the next step to then assign this function to our population column here within the pop_df, and then assign color to each of the values. So this is what we're going to do. We're going to create now a color column, and then this color column is going to use this pal function that we just defined, and it's going to apply this function to this one, so to this column. All right, so then when you run all these things, I want to actually show you what this means, what this color actually means. And for that purpose, I'm actually going to, I'm going to actually open this pop_df. We can just expand this quickly so that you can actually see. Okay, so you can see here that we have color. You see the hexagonal values are now assigned to each row, based, of course, on that function quantile probabilities that we previously defined. Awesome, guys. We are finally ready to write a code that will create a 3D population interactive map of Switzerland. And our first step here is to define a set of properties. That is to say, how our interactive map is going to look like in terms of color, opacity, tooltips, etc. So there are several things that we want to define here. The first one is question, do you want to have lines around your polygons? And here I want to turn them on, so I'm going to put stroke equals true. The second one is, do you want to fill your polygons? So yes, we do. So again, it equals true. The third one is whether you would like these to be spikes, so to have a 3D look, and this is the option extruded, which also we put to be true. Finally, there is something which is called a wireframe, which allows you to create lines around the bases of your hexagons in this case, but polygons in the case of SF object. So I'm here going to go for false. Of course, you can play with any of these options and see what works best for you. Okay, now speaking of extruded here and creating spikes, one thing that you can also define is something which is called elevation scale. Now this argument allows you to increase or decrease a ratio of the spikes. So make the spikes higher or make them lower. So for example, if I take elevation scale 1, basically it's not going to change, because if you multiply something by 1, it's the same value. But if I put here 2, basically spikes are going to be much higher. And also if I put 0.5, they're going to be much lower. So I'm just going to go here for 1. Again, you can play also with this option. Now we come to the part where we define colors, and this is managed using, first of all, get fill color. This argument is specific, is going to decide how our polygons are going to be filled with what color, and is there any kind of a variable that defines that. So in this case, we're going to be defining based on this color column that already have in our SF object. Okay. The same way we define this, we can also define line color. So these are the colors that are around our polygons. So you can, if you don't want them to be colored anything specific, you can opt for a constant value, let's say white or black. But here I would like them to follow also this value based on the color column. Okay. And then one of the things that you can define with respect to the elevation is called get elevation. This one again accepts a variable from your data frame or from your polygon, to be more precise, that is going to be used for that. In our case, we would like spikes to be as high as the population value is. So that's why here we're passing population. You will notice here that I'm using lambda, also this sign lambda, and then followed by the name of the variable. So this is the R way of doing things, but there is also a JavaScript way, because remember, this was built based on the JavaScript, so it does accept. And now I'm going to show you how you can actually also employ the JavaScript here. And for this one, we'll be calling actually polygons. We'll be getting polygons importing this map. And for that, we use option called get polygon. So here, because we want to use JavaScript, we're going to be calling backgl and JS function. JS stands for JavaScript here. So here we need to pass it in the form of a string. And then in JavaScript, the thing is you need to define your object from which you're taking things. So I'm going to define our object as D. So this is simply a formula. And then what I would like to do here, this is like a pipe that you write in R. So the pipe in JavaScript would look like this, equal signs greater than. And then you say what you're going to select from this. So this is basically a select statement. So from the object D, I want to select geometry. In our case, geometry is called geom. And then within geometry, I want to pick all those coordinates that create a specific polygon. So I'm going to ask also here, I'm going to add dot coordinates. Okay, so this is how you get polygons imported into your map. And then there are some other things that you can also do. And one of them, for example, is tooltip. Tooltip allows you to get a certain text based on your values once you hover over your mouse. So in our case, we could perhaps get population counts once we do that. So here I defined here that I want to see this population string, which is going to be constant, springing up. And then what do I want to show here? Well, I would like to show population from our data. So I use this double mustache brackets. And then within this one, I simply define here the name of the column from which I'm going to take this population count, which in our case is called simply population. And then one of the last things in the properties that you can define is opacity. So this is how much transparent or not your polygons are going to be. If you choose here higher values, they're going to be less and less transparent, so they're going to be more solid. And if you choose a lower, they're going to be more transparent. So why would I go here for 0.25, which is actually pretty low on the range from 0 to 1, is that I would like that you see also the base layer there, which we're going to also add, so that you can associate the population count with a certain place name on the map itself. Okay, let's create the interactive map. Here I just put the centroids of Switzerland because I would like to focus our view on the Switzerland itself. And the way to initiate the map here is simply calling deckgl from deckgl. So the function has the same name as the package. And here I'm going to define the latitude. This is this value that I chose. And the second one is longitude, which is the second value in this list. And then you can also choose the zoom here. So I'm going to choose a bit lower zoom because I would like to zoom out a bit. So if you choose a higher value of the zoom, then it's going to zoom in. And there is a fourth value which you can choose here. It's called pitch. Basically, this is the angle that you will use for your views to create a certain 3D view or more 2D view. So if you go for pitch, which is 0, you will have a completely 2D view. I'm going to go for 45, which is basically 45 degrees, to have a certain 3D view, of course. And then we should add the polygons here. So again, we're going to be calling deckgl, which has a function which is called add polygon layer. Within this one, we need to define our data. In our case, that's pop_df. And then you need to define the properties. Luckily for us, we already did that. So we're just going to say that properties equals properties. And then the final thing is you can add the base map. So you can, for example, go here, deckgl, and then add base map. So there are two options here. You can either use Carto, which is for free, or you can use Mapbox, for which you need a token. I will not be covering Mapbox, so I'm just going to be using the Carto here. There are 3 Carto styles, and the one that we'll be using is a dark theme style. The other 2 that also exist are light themes style, so you can check actually deckgl and see what are those 2 and whether they work for you. Anyways, so here we're going to be again calling deckgl, and we'll be using Carto style. So within this one, you can define different, as I said, so dark matter, positron, and Voyager. We're going to be using dark matter, which is here by default. And voila, here is the map of Switzerland. So you can actually move it, you can zoom in, and you can also see here the 3D outlook of your map. So basically the hexagons were extruded. You can also see the population count based on the Kontur data once you hover over it. And of course, the colors correspond to the population size. So the lighter colors are associated with higher population count. And as you go to darker colors, they are associated with a lower population count. It looks pretty awesome. You can also see here the names of the places, so cities and villages alike. One thing that is missing from deckgl and also this map is the legend, which is currently in a development phase, and I wasn't actually able to add it here to the map, even after trying several times. So that's something that we definitely need here to better understand, these quantiles that are presented here. But overall, this looks like a very effective way of, presenting your data and showing it to your own stakeholders or your colleagues. And of course, it's a very, very easy way to do it. And this is how you create an effective 3D interactive map of population using Kontur population dataset and deckgl in R in a few easy steps. I'm really curious how you take this tutorial on a journey across the world and apply this tutorial to your own use cases. If you're interested in replicating today's analysis, I prepared a link to the GitHub repo in the description box below, so do check it out. If you have any comments, questions, or just feedback, you can reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your knowledge of data visualization and geospatial analysis with R, I prepared a few cool tutorials for you, so do check them out. See you next time.